Okay. We'll talk about the innovative solutions. Thank you very much. Thank you to all those who come to us, everybody who is online with us. Thank you, my colleagues. My name is Alexey Nesterenko, and I'm Director Strategy and Operation KPMG. And for fourth year already, I'm participating in digital sessions on MINEX. And every year we perform better, and we have more and more solutions, and they also become better and better. Like 6 years ago, we have to choose from some pilot projects and to prove that this really works. But now the situation has changed, and we have a lot of solutions, and we have to choose the best one. I think this is fantastic. This is perfect for the industry. And today we'll listen to the exact some cases and companies. And the floor is given first to Maria Bычkova from Schneider Electric. She will speak about their solutions. Maria, floor is yours. Good day, dear esteemed colleagues. My name is Maria Bычkova, and I represent company Schneider Electric. Please, my presentation. Today, we'll have 3 reports. The first one, then Aveva company, because Schneider is the main shareholder of Aveva company. And we may say that all software solutions of Schneider are in the assets of the Aveva company. And then Klinkman company, this is the official system distributor of the Aveva company, and they'll speak about the implementation of the digital solutions. And they'll speak in general about our approaches and the concept of Schneider Electric in the field of digitalization of the mining and metal industry. So what are the drivers of digital transformation? We speak a lot about this, why we have to be involved in this digital transformation, first of all, and we talked about that yesterday. This is, of course, the market environment. When your competitors, they are dealing with the digital transformation, they increase their efficiency, accordingly, they can produce products and services in a more efficient way. Thus, they become more competitive on the market. And those who work in the same sector, they also have start thinking about digital technologies. We also talked about it yesterday, and not once, and I'll speak about it in more detail, that we need to attract new qualified people to their sites, because personnel, they also now have a choice where to work, and of course they prefer to work at the modern enterprises. Now, on the market, we have all the conditions for implementation of the digital technologies. These are cloud solutions, augmented reality, digital twins. It means that technologies have already reached the level that have been tested on pilot projects, and now they're used in mass scale. But digital transformation, at the same time, it is within some limits. Business imperatives, these limitations on CapEx and OpEx. You cannot just take all digital technologies. You should seek, first of all, for the outcome of the implementation of these measures and these activities. Let's come to the solutions of Schneider Electric. First of all, we think about the matters of cyber security, because whatever you use, either the digital block or planning system, or maybe mobile assistant of a person who is checking the equipment, we need to protect this data. They must be reliable, they must be safe, that there will be no access for anyone to the system, and the implementation of these technologies must be performed absolutely safely and secure for the enterprise. And we have 4 main areas of using the digital technologies. First, this is Industry 3.0. These are the technologies which are used in the site itself. This is automation of the production, different tools that can be used by the operators in fields. I'll show it in more detail here. So then next we go to the Industry 4.0. These virtual twins or digital twins. This is the virtual production, when we can have the entirely simulated models, and we can watch how the changes in technology will impact technological processes. We can also use them for training our people and to use correctly the equipment and to manage the process. The next level, again, the Industry 4.0. These are integrated dispatcher centers. Now see the trend that dispatcher centers now place to the more comfortable conditions. It means the operators can work in a centralized unit and they're taken away from the sites. It means that the operators work in the more comfortable conditions in some, settlements, not in the field, which is very relevant, especially for the northern areas, for the northern regions of the country. We see the same trend in Chile, for example, and our company, we also have this experience, and the Weber company, they also have this experience. When the dispatcher study or control center is taken out, is put into the city, it's much more comfortable for them to operate from there. And the next area, we apply the digital technologies. These are analytical centers where we can use the internal competence of the company, also work with the outsourcing companies like external analytics, to analyze the usage of the resources, other funds, analyze data on the operation of the equipment, and to provide recommendations based on the digital architecture of Schneider Electric. And the Weber has several products that cover the life cycle of the enterprise, starting from the design stage, even starting from feasibility study, then design of the object, then the development of the documentation, technical documentation, the plans of setting up the site, and then increase of the planning of optimization and increase of the efficiency of the production. Also solutions on the effective maintenance of the equipment, and also decision and solutions how to apply the best way different kind of assets. Here I will speak about the main directions about digital technologies, which seem the most promising in under the Russian conditions. First cluster, this is the solution for involvement of the personnel, engagement of the personnel. It's very relevant to many customers because, the sites may be located in very hardly accessible areas, and people prefer to work in large cities, so it's very difficult to find the qualified personnel. In order to attract people to these sites, we have to follow the trends, technological trends. What can we propose here? First of all, there's virtual reality, augmented reality, and connection to the work. What does it mean, these technologies? First, virtual simulator. In this context, we understand that we can train personnel remotely using 3D modeling, and thus an operator or an employee, before they come to the station, to the position of the inspector as a checker, on the virtual model, they can learn how the equipment functions, how to perform correctly using these simulators. And this is attractive to young people and to many other people, thus to enhance their qualification, to be more advanced in their profession. They understand if they use an advised company, the one that applied this solution, then they will be more required at the labor market in future. Also, we propose different solutions on augmented reality. Here we speak about the maintenance of the equipment and also about training of the staff. For instance, if you come with a cell phone or with a tablet or with any other gadget, if you come up to the equipment, you can put the camera on the equipment, and then you'll see what to do here. On the video, you just can see how the operator wear glasses, and the operator understands what to do. Or while you're inspecting the plant, for example, if you put your cell phone or the tablet on the certain mill or flotation unit, then you see the KPIs, what is the load of the unit, what is the energy consumption, and then you can go deeper into the technological information and to check the main parameters of the equipment and the process. Next, we have the complex of solutions that allow us to use the possibilities of the mobile apps. This is for the inspectors of the equipment to form automatic orders, automatic tasks on different types of activities in the site. The inspector, for example, practical, there's no need for him or her to check the equipment, but when they have to come up to the equipment and to use their barcode from every piece of equipment and to perform the certain procedures which are stated in the app, then it's much easier to check it. And also it's easier to form the task for the operator, for this inspector, and then to release the report after the inspection. The basic thing for digitalization, according to our opinion, and we see it on in the sites, on the facilities, this is to meet the requirements on Industry 3.0. This is automation of technological processes and we have the complete line of products starting from the control with the software for automatization of the upper level. And my colleague from Klinkman company will give us the exact samples on automation. And here I would like to mention that we have the standard library as far as the solutions are implemented in many sites and many facilities. There are standard libraries, and it makes it much easier to set up the system and to introduce the automized system. And the next trend, and we see it all over, these are integrated dispatching centers. Here we talk about the thing that in one premises, under one roof, we can put together the entire information on different assets of the company. It means that the personnel from different sites can exchange information, can share best practices, their experience, and also to follow in a centralized way their situation on efficiency, on safety, and different, and activities on different sites. Here I would like to give you some examples, and my colleagues will talk about their cases, about the projects that have been realized on dispatching centers. Another very promising trend, what we see, and when we see the system automatization in many enterprises, we now see the complex solution. This is integrated planning and optimization, so-called connection of the planning system, starting from the mining planning up to the production planning, and System S. Linking these systems, we can get data from production or real time. We'll then recalculate our plans and introduce corrections for the task and send them back to the MES system. This is a system of managing the enterprise management. And then we'll speak in more detail what are the benefits of using these systems. Now also we see the trend of predictive maintenance of the equipment. This is not a new technology. We already use the artificial intelligence and also different mechanisms of data analysis on the operation of the equipment. We have collected a lot of statistic data on equipment. Thus, we can use already well-tested and well-established technologies to reduce time increase time of equipment usage and correct organization of management, depending on their real condition. We also have several offers in this field, and we are ready to share with you our experience and our knowledge here. And one more thing, when you're talking about digitalization of the plant, this is not just the ERP system or MES system or planning system. These are roles, and we say it's quite important. This is one of the basic things. This is digitalization of energy consumption. Here we talk about the accounting of the energy resources, then installation of the substations, and also we can interconnect on the systems into one network to manage the whole the whole system. This is your own generation, then optimization of the costs and obtaining of the energy from different renewable sources and other sources. And it's quite clear what is the effect of this system and also the impact, the enhancement of the reliability and durability of the system. It's a smart system. So this is the end of my presentation. If you have any questions, please, you're welcome. Maybe in the end of the session. Now I give the floor to the next speaker, Sergey Mashin, Aveva Company. Thank you.
So now I'd like to continue just to follow what Maria has started already explaining. I'm going into greater detail into specific solutions that are aimed at optimizing the production and commercial chain. So Aveva, our company as is now. So if you are from the mining sector, I mean, you just be having our solutions, pipe under wiring. So these are the solutions that we are providing, and lots of revenue that we receive will be then investment into R&D projects, and we have a very serious roadmap for developing software products that would support all stages in the life cycle of a mine. So we start from this conceptual and design stage, so with assessment, availability and feasibility, through the management of construction and engineering, to the management of current assets, optimization, and then until closure and remediation. And then I would like now to focus our attention on this spot that is highlighted. So we are talking about production commercial network, and there are two strategies at play. So first, optimizing supply chain, just optimizing calendar planning, and we try and remove all obstacles that can be in the interaction between various business units. And the next big thing would be removing bottlenecks through identification, root cause analysis, and then identification of actions to prevent any such situations. As you know, I would like now to be with the general trend with those slides and charts that unfortunately we cannot just read very well, so it's not very eligible because there are lots of data and explanation for all the stages and process in the mine. So now we can get a more clear picture in terms of planning and performance at the MES, so the operations management level. And so there are different levels of detail and performance. So we go from years on top and then to seconds at the bottom of the slide. Now these will all involve processes and people. They talk to each other, they make decisions, and so you can see arrows that represent points of integration and the time that is required for exchange of information. So we reduce actually this operational time because they can be seen as a loss of money, and to the company have actually spent too much time on it. So these are root causes, probably some extreme cases, and the idea is that These are distinct blocks, but we know that people, they're working with spreadsheets or other solutions. Just the idea is that these are all isolated elements of the system that are being supported by their algorithms. They have their own constraints, and it's a big question mark whether they can be integrated, whether they can be connected, so that you clearly see that we don't get spreadsheets. I mean, for instance, for days and daily planning, so ERP, that just enterprise resource planning, also something that has been there for 10 years, and just a decade ago the people decided that was a must, and then not all of the things have been fully implemented now. So I've already mentioned that see that the time it takes to make a decision sometimes will lead to losses and also failure to achieve the target. Just this interaction also will, and the efficiency of operations will depend on people providing that exact bit of information. So to remove problems, and we suggest the following solutions. So this is the calendar planning or the scheduling exercise that need to talk to the production system, and also there should be communication between the two systems with one vital block, that is HR management or people management system. So people, they also need to communicate in the right way, and then they need to send their data sets in the right way, so shouldn't be working in silos. So that is why we've decided to put several solutions on the market to minimize points of integration on the one hand, and to make this better use of models that are tailored to specific tasks on the other, so that the spiral product to optimize scheduling and planning and to manage supply chain. So that is now called unified supply chain management, and it is based on several levels, and you can also have one task, and then, for instance, a customer also may decide to use it in one way or another, and then we have another solution that is workflow management system, that is a kind of glue between systems and people. So this is how it looks like. So two products that help address the tasks and all these, errors and lines of interaction. So you see that it goes seamless, and people just do not notice them. So the supply chain management and planning system, again, as shown on the screen. So there are this is a model that resembles a flow sheet, and then you can find an engineer, so that would help designer to build a model. So it is very friendly. It contains no acronyms, no just complicated terms. It's made for people, and it's made by people and for people. So it is unified for all kinds of tasks. So that's planning of works and calendar planning, also supply chain management. That would include a multi-plant and multi-factory. So many enterprises can be then brought together under one supply chain management. That is just one single platform, and there is no need to have its elements integrated. That is a breakthrough technology on the market for today. And in other slides, I know that you have seen it before, but just let me dwell on some of the specifics, the ways that we establish that interaction between supply chain and control rooms or operations. So then once we receive this schedule from the planning department, then we get the workstations. So the workstations would be sending data on downtime and also information that will be used to make this plan versus actual analysis. Also, it will be sending data on the location of materials at production stages. So similarly, they will receiving KPIs for job tickets and orders, so that just we're going to go through a loop. So that is going a loop cycle, and we see that the company, they have their budgets for ERP, so that can be linked to specific measurable indicators, and you get this very transparent end-to-end process through the value chain with your company. So up to a single just a sensor. So you get the sensor just telling just the wrong reading or the wrong number, and you just make a mistake with a shipment and you get penalty under the contract with your customer. So these kind of situation can be prevented through the system and the supply chain. So the next step would be advanced process control. So this process, and we need to be stabilized, and product quality must be stable at all times. So planning will be also factored into the quality management system, and there is one business driver that is going up for productivity and going down for energy consumption. So if your company would like to prove to management that digital reforms are needed, so you can use this technology as a great way of making your case before the company's leadership. And by the way, the return period just 6 months. I mean, I have never heard of any just case that would be like 6-month periods for return on investment for the mining company. So this is something that is proven and very attractive. So that economic benefit that you get from the introduction of the supply chain management system is evident, as demonstrated on the slides, and based on our experience with other companies, that would be the cost reduction by 2% and revenue increase by 1%. So this the technology that we are deploying also help do away with the bottlenecks and improve productivity. There was a single case when just the productivity went up by 50%, but this can be compared to a situation when you're losing your wallet, when you turn off the light, you turn on the light, you suddenly find it, and that's it. So it's like miraculous again. But that's okay. That's it from me, and I'm going to pass over to Sergey, so he'll be more on the practical side during his presentation.
My name is Sergey Tsvetkov, and I represent the company Klinkman Wonderware Russia. We are the distributors of the software products of Wonderware, now Aveva, for about 20 years. For more than 20 years, we are responsible for Russian, the CIS and mining industry is one of the priorities for us. And today, I would like to share with you in some details. We will start from general things to some more detailed things. And so I'll speak about some cases, the stories of implementations of the products. I would like, okay, if you look at this slide, you understand it's eligible because, but we may look here what kind of software we propose. To sum up this slide, we offer different types of software products, Wonderware, now Aveva, for different levels of management, starting from the local systems and up to the corporative systems of management, corporate system of data storage, personal management, planning, and so on. I cannot but use it once again, this slide, because it's well known, the joke. When you look at this picture, that's already not a joke, because we can see what is Microsoft Excel system, MS. What is dangerous about this image? This is really a great job that done. People at the enterprises made a fantastic development in Excel, and you could imagine how it is complicated to support all this, how to bring it all together, to link everything, and how to use it later when these people leave the enterprise. You see, it's inevitable. Yesterday and today we were talking about these problems related to the staff, to the personnel, and this is just about this. So what we can offer instead of this, we offer the complex solution from the global leader on the market, well tested, well established, and tested by practice. So our leading, Weber leaders, is confirmed by the Gartner's report with the Magic Square Invest for 2019. And what is still more important, or maybe more interesting, you can't see years. I don't know why, but you cannot see the years. The previous was for the 2019 and 2021. We are among the leaders again, although we see the toughness, very tough competition, and you see there are now new leaders come, and we have the new people there, new leaders for more than, they have changed for more than half. And another very important factor, that we have cases, and the majority of the cases that I show you, these are our Russian local examples, local cases of the implemented projects. This is the expertise of our partners, of the system integrators, those who are involved in integration. You remember Norilsk Nickel, they were talking about the technological breakthrough. Everyone knows about this. This is one of the first projects within the technical breakthroughs. That was PINS, the Cooperative System of Data Storage. It's a basic project that was used, PIMS, which used as a source and, example for implementation for the other projects. And I want to give the floor to Trapezin Director on automatization of Norilsk Nickel about the sources, preconditions, and goals of this project. We faced the thing that there were more than 200 systems of the level of ASUTP, this is automatization level, means more than 70 different systems which are related to the management of the enterprise, accounting system, but they existed by themselves. They were not interconnected, they were not integrated in the processes, business processes, data flow, no common reference documents, nothing. So it was so difficult to get a document where we can see the situation or the signature of the master. It was impossible. We have so many information. A lot of, you say, it's a real richness, and we need these documents. But what to do? How can we apply it in our everyday practice? How to live with all this? What to do? It means that we have to stop to ask for documents from each other, and we must have a system where we can have the whole information which will be sufficient for all levels of management. And the next project, within the same framework of technical breakthrough, it was dispatching of the production. It was implemented in Nornickel in 2 sites, in one of their branches in Zapolyarye and GMK. So what the results of this? All the dispatching logbooks and reports for the management were done in a digital way, it means paperless, documentation flow now, and some figures and some intermediate results of the first stage of the technical breakthrough. I'll give the floor to Dyachenko, the first vice president of Nornickel at that time. So you see here the stages. First stage up to 2018. And a strategic session, we had it in London very recently. We presented the first results of this preliminary stage. We have increased our production volume 7% due to these programs of increasing efficiency due to digitalization. And we also increased the productivity per one employee 15%. So this is just in very few years due to all these digitalization and digital solutions. So the next stage will be marked that we are going to increase the efficiency of our production, not less than $40 million. And then we'll look at the planning and better understanding of our resources, our stocks. Then we're going to enhance the quality of the ore which we process. The expected efficiency up to 2030 is over $400 million. So that's about the payback, and that's about the effects, where we can find this, efficiency. They're here as well. And the next project, this is MES of the mining refinery complex. What was peculiar about this project, that it was implemented in parallel with the bringing this enterprise on the designed capacity. And the second thing, in this project, the operative part of accidents liquidation was put into the digital way, and it was done a year and a half before this requirement was put as a mandatory one for all underground enterprises. Vystrensky, they have just the ground, open operations, but still it's very interesting. And Dmitry Pshichenko will speak about the results of this project. At that time, he was the director on information technologies. I'm not going deep into the figures, just let's discuss the results, the outcomes of we reduced the paperwork because we're now not using not the paper, but we store everything digitally, and our line managers can always have the access to the system and to see the current reports of the activities of the production. Now, at the same time, together we have the e-book of the downtime. It's also very helpful in terms of analysis of the information. We also have the database of the operational information, and we have less people in the fields now, that we can remotely control a lot of our equipment. And this is the same. I think if you introduce this system of dispatching, it means that you reduce your personnel, the number of employees. And the next, this is monitoring of the raw materials and semi-ready products or commercial products. That's another very good example when we have very exact business goals and tasks. And these goals and tasks, when while implementing the project, they were achieved, and they're very specific, particular for this enterprise. But still, it's more interesting. It's more representative this case because that the possibilities to achieve these business goals, and it was possible due to our software products. Oleg Davidenko, the head of the MES practices, he will talk about the goals and tasks of this project, of this system. Another peculiarity of this project is at the very beginning, at the start of the project, we began with a pilot project, our system integrator. We use our system integrator, and our developers, when they acquire the necessary skills and competences after training, with their own efforts, they continue to develop this project. So they already have the internal team of developers who are ready to implement the product completely and also ready to work with the, external orders. But there is a lot of things to do at their own enterprise. The system is developing, the system is very active, and it's very interesting. So in general, about one of the flows, this is gold fall. We reduce the time 30%, And here we see all the advantages of, and we became better not because we just use this MES, but we use it as a tool that allows us to implement our initiative, our strategic initiatives of the company. And the last example, this is the only example of the implementation of this software in the foreign company. And this is what we want to show. These are united dispatching centers, control centers. This is Asman Proprietary Limited, one of the leading producers of the magnesium ores. 3 mines were united, and the complex of the ground sites were united into one dispatching center, one control center. The key peculiarity, again, of this project, we have achieved the increase of the productivity up to 10%, and Sergei mentioned about this as an average figure. And director of this enterprise, BlackRock Mine Operations,
plant efficiency, operational efficiency, and also to engage with the employees out in the field that need to deliver. So we've seen an increase in uptime, we've seen a dramatic improvement in safety, and also nearly double-digit growth in productivity. At BlackRock Mine Operations, we are excited as what we have achieved up to now, and we're equally optimistic about the future to deliver on our vision as a team to become the best underground mine in the world.
Ну, если вы расслышали, еще одним важным.
So if you heard it better, one more result of this project was the achievement of safety. Yeah? This enhancement of safety, and this is very important for our South African colleagues. This is one of their priorities, and I'm unfortunately limited in time, but I would like to say that we do have the demonstrative booth prepared by our partners, and we can show you from the inside this conceptual architecture for the control system. So we use the following software product. This is GEM platform for the collection and processing of data. Then AvivaMS, which is used for structure and aggregation of data using the production model of the enterprise, and Avia Work Tasks, which is used for the implementation on business processes and web interface of the user. On demo booth, we look at the production process of the recovery of the ore and also uploading of them. So that is all. If you do have any questions on the demo booth or maybe on the presentation, please, we are ready to arrange a special session for you. Thank you. Thank you, colleagues. Now we pass for a complex of 3 presentations, actually. Now I want to give the floor to Alexei Tsoy, the Chief Technology Officer from Bystrinsky Mining and Concentration Plant.
Good afternoon. Colleagues, I would like to invite Viktor Maslov because we just put together this presentation with my colleague, and that's the presentation about the Bystrinsky ore mining and processing plant, and we are quite heavily involved in the implementation of the innovations, and we are also certain that business processes preceding innovation should be optimized in the first place, and then they can be supported by innovations. So we strongly believe that there is a theory of constraints that can apply to our production, and we would like to explain more about it by giving you a specific example. So for those of you that may not be aware of this theory, so let me explain that it's been developed by Coldrex in the 70s and the 80s. Probably you have seen the book of Purposes or Goals, and some people may think that it has nothing to do with the mining sector, but it has, yes it does. And we have seen numerous examples where this technology and philosophy has been successfully implemented in mining companies. So first there are steps in the process, and we start with bottlenecks. So when people say that, oh, we got lots of bottlenecks, no, that's not the point. It means that you don't get it because you should have one bottleneck, and all other problems, they just can be treated as noises. So it's all about noise in the process of production. So once the bottleneck is identified, we can then maximize the use of this bottleneck, and then we also go through the decision-making process, and we make sure that all decisions that are taken, they will be serving the final purpose of the bottleneck exercise, and then the capacity building will be another function associated with it, and then we'll be doing it in a circle, so that here's the mining production, and as presented in several levels, that going from ore, the resources, ore processing, final products at level 1, so the high level of detail, then going down into greater detail, and then yet we have several levels to go below or to individual tasks, and also from exploration, excavation to the mill, and then the result or the finding that our finding, what that was, the chemical analysis laboratory actually was that single bottleneck in this process. At every stage we had to wait for analysis to be delivered by the lab, so as the classification, so grade control, blendings, and so on and so forth. So then we decided to focus on this process to increase efficiency and effectiveness of laboratory operations. And I would like just to make one important point, because the same kind of approach we have employed to boost sales, to optimize the quality of finished products, and looking just at an enterprise through this integrated lens. I mean, you can go from the company as a whole and then into separate blocks of it.
В жюри одного конкурса и выступаю здесь, поэтому я прошу прощения, я передам слово Виктору Маслову, который, собственно, продолжит доклад. Спасибо.
Спасибо, Алексей. Я продолжу доклад.
Thank you so much. So, Alexei, I'm going to continue this presentation. So we have done with the theoretical part, and now I want to continue and explain how the theory can actually apply to practice. So what we have done and what steps have been undertaken to make it practice. So we'll be now looking at all the processes that the lab goes through, so that sampling. So first samplings will be carried out as part of exploration. So prior to analysis, a sample prep is required. Help it dry, they will be milled to get the right size of the fraction. So that is at the very stage that we realized that there were problems or problematic aspects of productivity at the sample preparation stage, and that was already constrained to the system. So just a sample, while they were waiting for the samples, they had just samples that like work in progress, and that led to accumulation, and then they couldn't produce as many samples as they were required to. It was 100 samples per day last year, and the capacity was there to receive 360 per day. So that just so we analyzed this sampling process, like samples were received, and then as I said, they were milled, and then they could just also catch up on it. That we just analyzed that they underperformed within 1 month and they overperformed the following month. I mean, that is not a catching up exercise. I mean, no one will be waiting for them to get samples prepared, because this is a continuous process in production. There are plans in place and the processing just waits. So as I said, this production process is continuous. And then we started to analyze. So you see that sampling curve, there is a blue line, and then so we compared it with the productivity levels, and we see that this sampling incoming samples can be also in higher and lower amounts. And then on the one hand, just there are no processes within the time allocated for it, and on the other hand, if we can see it as a constraint, then we need to focus all of our efforts to make sure that we make the maximum use of this particular constraint within the system. So on the one hand, that was on the one hand, but on the other hand, we see that productivity is going down due to the lack of samples. So we didn't have that. There was a shortage of samples 1 week, and then we caught up the following week. And I'm looking at the trend. Just there are some gaps that will not be able to compensate. There is time lost that will not be offset. Next periods for sampling, we have this very good example, because at the end of the month, so we had collected samples, and then on a given day they received lots of samples. That was a snowball effect, and the samples got accumulated. So we decided to address that problem. So we started with managerial actions, and these were supported by technical actions. So on the technical side, new equipment was bought, and this grinding and milling line was put into operation. As for managerial actions, then we optimize processes, interaction between people in terms of maintenance, and putting the equipment offline to reduce downtime, to make sure that efficiency and productivity is there. So as a result, we just grown 2 times, so up to 200 samples per day. That's August August this year, and we see the sample preparation level per day. So we can also see this is the trend. So the trend doesn't change a lot, but it's more about the downtime due to the shortage of samples. So we decided to create this sort of buffer zone. So these are the probes that we take from in-field drilling, because these used to be all outsourced in the past. So finally, we now get this not as a constraint. So it's no longer that critical. So we see when we are running out of samples, that can be detrimental to productivity. So we now will be taking samples from the infill drilling, and this maintains the overall productivity level for the enterprise. So going just further in the process, a sample will be received by the chemical analysis laboratory, and the laboratory has its analytical department, the chemical analysis and spectral analysis for copper, iron, and silver. So also the in vitro, so that it will be used for gold concentration analysis. So when we look at the analysis, just this, this red-colored unit, because we were receiving more samples for gold, and then they also had this kind of accumulation of gold samples. So in addition to the samples received from the site, they also all sorts of samples, geological, commodity samples, and then all things were urgent and important. So, and we had to look at it in more detail, because this was another point where a bottleneck could be identified. So went further to analyze the process, and then we realized that was crucible melting actually as another bottleneck in the process. So that's like up to 400 so items per day could be processed, and so that crucible, and there was only one at the time, and then we just couldn't put another furnace very quickly, because then we had to change the ventilation system, then we had to calculate both capex and opex and to make it as a project. So there was no way to obtain a quick result from this for this part. And so just alongside we optimize the scheduling of shifts to make it better use, a more efficient use of this crucible, so that managerial actions led to concrete results in 2020. And you can look at the graph, that is a blue columns. So in 2021, so the upgrade or refurbishing project was completed, and new units were put into operation. So now you see that productivity is on the rise, and actually this is an upward trend indeed. So our next example is an analytical unit, so that was more of a prevention. So we had this prediction for magnetic iron, and they used to have chemical analysis, and then which took lots of time and effort, just up to 200 samples per day. So the decision was made to buy a new unit to improve the efficiencies. Just from 2019 to 2021, we clearly see that it's like a double digit rise, and that's the targeted system for sampling with our chemical analysis laboratory. So no further bottlenecks that can be identified, and then for this particular unit that we had, I mean, just with in vitro, and then it's no longer in red. And to conclude, I would like to say that just increasing the productivity of the chemical analysis laboratory actually was thanks to this, clear identification of constraints at each and every stage of the process that did not allow us to improve our efficiency. And at the same time, so we need to also emphasize the important role of preventive actions, and that could include managerial actions and also some technological solutions, such as buying new equipment, for example. Then we just clearly see that we are performing quite well, and then this is thanks to those actions that I already explained. So when the refurbishment, you see, was over, so the performance, continued to increase, and now we're well prepared for the challenges awaiting us in 2022. Then thank you very much for listening. Victor, thank you so much. Just to continue with the lab, I would like to give the floor to Irina Bessona, Project Manager, Termo Techno Group of Companies.
Good day, dear colleagues. I'm happy to represent today our new project. It's an innovative project, automized fire assay laboratory. And it's very good that we are going after Bystrinsky GOG. I think this is our future customer, I'm sure. So this is the project on the development. It's operating project. It was the release of the project was this year. It was launched this year. Now it is in a testing period. And also, what were the preconditions to create this, to work on this project? First of all, because we need the increased needs of analytical control. This is the task for any kind of the assay lab or chemical and analytical met. When we see the demand and we have to increase the capacities of our lab and we don't have it, it means we have to perform the construction work because more orders come, but we don't want to be involved in these construction works. And as far as Norilsk nickel, the ores are very complicated in their chemical content and the very low expression of the analysis of the test, because the one test takes from 5 to 7 days. And this project wouldn't be implemented without the international team. And we have 4 countries participating in the project. This is Switzerland, Germany, South Africa, and of course the Russian team of the highly qualified engineers and developers. I'm talking about the software developers. Without them, we were not able to put on commission this project in this difficult time when we have to work on the pandemic with a very, with a lot of restrictions. But anyway, everything was done in time and we launched the lab. I also want to thank our customer, Norilsk nickel. The innovative product cannot be implemented without the innovative thinking of the customers. It's even like a heroic deed, their openness to the innovative technologies, to new methods. They allow this project to live, to develop, and to do it together with our team. So what is the unique features of this system? First of all, this system is just the only one today and the only one in Russia. It's only one in the world and only one in Russia. For this system, we develop its own technology, taking into account the chemical properties of the ores and technological materials of the customer. System consists of 3 robotized circles. The first circle is responsible for Tegel melting, and the second circle is responsible for the purification of matrix from the non-ferrous metals and sulfur. Thus we get the copper, and the third one is responsible for analytics. We use the optical spectrometer to get the whole spectrum of the precious metals which are of interest for the customer. The whole system is connected to aspiration system, as we have the aspiration unit, and this unit collects the lead dust, the dust from the feed, and accordingly the air inside the laboratory is completely pure. It's not contaminated with anything. So what are the benefits that the customer obtained after installation of this unit in their enterprise? The volume of the analytical control that was needed, that was actually the main task, we have implemented it, we achieved. We performed the maximum expression analysis. It means that during 2-3 hours, they may obtain the full range of the results of the tests on precious metals. We installed the system on the site of the customer. We didn't use any additional constructions, any additional rooms were not needed. We were able to put in quite a rather, small room. There are 4 robots there, and everyone is happy actually with this system. So I can talk a lot about the project, but I would like to show you some videos about our project and also the feedback of our customers. Please start the video.
Собранная нами пробирно-аналитическая лаборатория
This analytical lab that we composed, this is the one, in its way, fully automized laboratory, which allows, without people, to perform the whole cycle of operations of the assay analysis, fire assay analysis.
На риске тяжелые условия.
You know, in the risk we work under hard conditions for living, for example. It means that qualified people, it's very difficult to attract them to come to this enterprise to work here. That is why we have to think about this type of complex. First of all, to reduce the number of employees who work there, who can perform these operations, also to increase the efficiency of the production. And our methodology allows us to perform the tests of the precious metals within 5-7 days. This is just only time for testing. This is too long, and this automatic line allows us to perform the tests of the precious metals in 2 hours. It means not only time, but also the quantity on this system, on this production line. We can increase the number of tests that we can perform. The more tests we do, the better is the result. And what are the unique features of this? What makes it so unique, this system? It's fully automated system, absolutely safe, closed system. And we can make tests without people. No man is needed there. Unmanned system.
О специалистах термотехно можно сказать только положительно.
Our engineers, what we can say about the specialists from Thermatech, they're very positive, very energetic, very involved and devoted. They try very rapidly to solve any problems that may occur. The more complicated is the things, and the more complicated enterprise we have, then the more problems we have. But now we can relieve all them with the help of the Thermatech specialists. Let's take the sample number 1. We put it here. It goes. In Norilsk, we have a very rich ore, stocks, and to develop it in the most efficient way. Then we perform exploration works, geologists, and to have the reliable data of this geological exploration and to process them timely, we're going to use this complex. What is new about this method and what is so unique about this system? We have 3 circles here. First circle is preparation of the sample. This is the first Tegel melting, where we receive this type of sample. This is the lead cupel, and we correct all the precious metals on this reference sample. Then we separate this verbel from the slurry. Then it goes to the second circle, and here we have the process of coupling. Why do we need this coupling? In order to purify the lead matrix and to remove all the unnecessary precious metals, non-ferrous metals, and after cupel, the sample comes here, and here we perform the grinding of the surface, and then we put it on spectrometer. The spectrometer performs the analysis of the content of the material, and in parallel they perform measurements. And then we have the average results, and the results go to the enterprise database. This very complicated setting, here we can get the chemical content of the material, and it is very rapid. It takes just one test takes about 1 minute, and the results are stored in the database of the computer during several years, and according to the request of the operator, you can check them. You can check any kind of result and compare it with the reference sample. So it's very complicated project, you see, because we have to integrate it into already existing enterprise. Thermotective, from the moment of designing, from receiving the URS, they started the supervise and control this project, and they're high-class specialists, from the chemists up to engineers, every one of them. And together with our specialists, you see the result. We have the completed line, which is ready for operation, and the engineering solutions in this lab were never applied before in Russia. So this is a unique object, a unique lab, and the first in its area. And we hope that the other customers will follow our example, and this will be only the beginning for this type of technology and this type of solutions. Thank you very much. Thermotech company works not for the first year. In terms of automatization, we have already implemented projects. We have also some projects planned for future. For the first time, we could take part in MINEX, and I think in a year we will be able to present the new automized laboratory with our new customer, PAO Seligdar, where we now install the automized line of test preparation of the test for test preparation. Thank you for your attention. Yes, thank you, Irina. So we have finished with the presentations, and now we'll have Q&A sessions from the floor or from our chat, whatever. We can discuss a couple of issues between ourselves. We talk a lot about the systemic solutions, about large solutions that are relevant to a Weber company, that about the automized labs, but quite often there are some skeptical, especially those who never were dealing with the automatization. What do you think? If you start with some small pilot project, if you want to prove the efficiency of the digitalization, what kind of project you will select?
That's quite a broad topic, and I suggest we need to start small. So remember, during my presentation, I just explained its control function, and then you need to secure this quick victory, and you can use this solution just for flotation purposes, and then it will be 3 to 4 return on investment period, and then the solution can be rolled out, and then there is some money, received from digitalization can be further used to finance other projects. So this is going to be quite a good result. And therefore, about this economic effect, this can be calculated, and we have the methodology in our company, Aveva, and also methods with our partner companies. So just we take this basic measurement, and then we see what kind of KPIs need to be added, and then we just use this numerical or this mathematical modeling models to see what will be the economic effect of the implementation of the new systems. That's even can be used for the mills. For the method, we have this frequency drive. So, as many of our customers would be willing to install it, then energy resources is yet another example of digitalization and energy efficiency. So, this is something that you can save, not just you can be efficient as regards resources that are difficult to measure. And the same goes for the lab, just energy consumption. For instance, if you look at the data for a month, and it's very difficult to pinpoint the exact date in which you overconsumed. So the integrated system of EMS is yet another example, and of course it is more probably difficult to get this concrete results, but it looks impressive indeed. And benchmark for Power Presley is all about predictive analytics and maintenance of equipment. Rio Tinto, Anglo-American, Norilsk Nickel, and Severstall. So these are the companies that have actually achieved economic effect in terms of some millions and even dozens of millions US dollars. I was going to say something about predictive maintenance, the one that Maria has just mentioned. This is kind of applied task, but you need to start with fundamentals and basic things such as digital hygiene. Just going back to the Nornickel case, and you have the specific element that will not be just calculated easily, and this element is needed. To get the result, to get the numbers that they do have now, that like pulse position modulation, because it's what it's all about. So in terms of equipment and equipment automation, so I believe that the minimum that was actually achieved at the ore and mining and processing plant, that they added more furnaces, and then the next step would be just automating these units. So Euroshizolt, another company that we're working with, so what they decided to do is to automate their lab, so that was like semi-lab installations that they bought to prepare samples for further analysis. And so that was the semi-automation. Also the methods, these are the standard methods that will be used for assays or analysis and in laboratories. These were the minimal steps that they established, and they form of the smaller automation units. And even if you go to like semi-function, that yes, you can find this kind of equipment on the market, and there are several enterprises already operating them in the mining sector and other sectors such as metallurgy. So I believe like step by step we can approach in the spaceship. And I'd like to say that I agree with the question about pilot projects. So just rightly asked, and about automation of production process, that's something that we didn't cover with our presentation, but we also delivered automation to the chemical processes, and just that was done relying on feasibility study, because we just wanted to see that the effect in terms of economics and also technology, and then going or rolling out this automation scheme onto other units of equipment. So just when you have this minimum level of capex, so you can measure indicators and see whether this will just deliver the desired result. And for analyzers, we just bought these analyzers, and we saw that the productivity went up for the acid and solution analysis, and obviously it also improved the safety with the operators or lab operators. They didn't have to contact with hazardous substances, and the same goes for spectrometers. Just one, when we bought one automated sampling unit, we conducted training, so the result was there, and then we bought new units. Just we took those spectrometers, and these were automated. So right now, when we have one operator that actually can handle several units. So anyway, my answer would be we need to start with pilot projects. Thank you. And I'd like to add that, when I asked my question, just what I was meant to say, I like stabilization, because I like all these systems that help stabilize processes and just to prove your business case before you start implementing it. And then second place would be business analytics, and just more systems that would be corporate center and strategic decisions with the company. And then career, also then open pit managers. So we need to focus our attention on them, because if we take this data set and to make it friendly to the open pit managers, so it will be just, can be done as a quick exercise, and it can be used very also conveniently, and this will improve productivity in the end. So as far as I can tell, are there any further questions? No further questions. Yes, my name is Andrei Minking at Continental Company. So it's a central department for R&D. And I work in Germany. So I have two questions to ask. First question goes to Bystrinsky, mining processing plant, and the drones. Are you using drones, or probably you may be planning to use them? Continental, like many other companies, so we specialize in specific equipment, and I'm referring to drones. So we have drones that can monitor conveyor systems. So then my second question is about carbon footprint calculation and climate impact measurement. So are you doing such calculations at Bystrinsky side, and do you publish the results, and then also the impact that the plant is producing on the environment? And I have another question that will be my third question, probably out of curiosity. So because I'm reading the news, and now big companies such as Rio Tinto and Anglo American, so their management have a motivation system, and their bonuses already linked to carbon footprint and also to climate impact. So my question to Narisniki, do you have the same kind of motivation system for your top managers? So thank you very much for all the questions. I'll be taking them one by one. So I'm just the head of the laboratory, and some of the aspects are beyond my competence, but I'll do my best. So you asked about drones. Yes, we do use them, and our specialists in mine surveying using them quite actively indeed. And we started to operate one drone, and then we bought more. So we're planning to buy more drones, and so we'll be using drones for your conveyor systems. So not yet, but we are using drones for mine surveying. So it's for the carbon print. So your second question, I'm just not able to provide you with any statistics, by the way. And as for KPIs and top managers and mid-tier managers, so their motivation schemes include efficiency, EBITDA, and also safety, plus environment. So there are specific actions that these are undertaken. So that's in response to question number 3. But as for the second question, this needs to be addressed to my colleague that is now attending another session. So just whether the carbon, tax, you may have heard of it, and the risk need, it has a large portfolio of experts and just supplying your products just domestically and abroad. I mean, there's a carbon tax will be taken into consideration. The carbon footprint should be factored into your calculations. Let me just comment on this. Carbon footprint actually is a very topical issue, and we know we all need to be striving to reduce it for the companies. And right you are, ArcelorMittal, Anglo America, and Rio Tinto. These are big international companies that have sustainability factor based on their carbon footprint, and obviously we are going towards this net zero for carbon and the 3 levels. So to be considered in terms of carbon emissions, that just combustion, and the second level would be just indirect, like you're buying electricity, but so because someone before this electricity just enters the grid, that needs to be generated somewhere. So then the third level would be emissions or carbon emissions from contractors. So that has nothing to do with like energy or thermal power. No, it's because if you're building a block and then you're buying equipment for your substation, so they will be just measuring those emissions from your contractors, the manufacturers of your mills, the manufacturers of pieces of equipment that you are buying. So many companies would be just relying on level 1 and level 2, but we are Schneider Electric, so we have 60,000 employees, and just by 2030, so we have that ambition of becoming carbon neutral. So, and reducing just our carbon footprint to 0. And so we are achieving that target through participating in various programs and providing consultancy services to various customers, including metallurgical enterprises. So for the international just rating agency that covers, big companies, including for the mining sector. So we're just ranked as the first global company in terms of sustainable development, and this rating uses carbon footprint as one of the key criteria for evaluation. You mentioned the KPIs for managers, and then so for the planning system, we can also use it as a cap. Plan your production, say 1 year ahead or a month ahead, so you can use it as a limit, and just to you can guarantee to the manager that so the production plan will be calculated given the carbon footprint. And by the way, this is already in practice because the top managers are responsible for the carbon footprint. So ArcelorMittal, yes, they have it. ГБРК. What about you? So them? I think it's clear because Severstal, so they're on the green steel trend, and now they're just selecting suppliers with a lower carbon footprint. So we see that this is third level, just the philosophy is there. So then gold mining companies, again, they would have this departments dedicated to sustainable development. So this is their area of responsibility. Thank you very much. Any further questions? No further questions, and I would like to thank our speakers and our audience and participants, and then I would like to welcome you to have the lunch break and to visit our exposition. Thank you.